Hi everybody, my name's Jason. This is a quick demonstration video for Blawx version 1.1 alpha. The big change that we've made to Blawx since the last version is to reorganize the way the app is built around pieces of legislation. So you start with a rule and then your code applies to sections of that rule instead of the code itself being the primary unit. So we have a rock, paper, scissors act demo, including with the software. What I'm going to do here is I'm just going to recreate that from scratch. So we start by going into the create rule, and we're just going to call this RPS2. And I am going to paste in the Acoma Ntoso code for our sample rock, paper, scissors act. And then we're going to hit save. And now we've got RPS2 right here. So we can go in and you can see this is rule 6 in the database. And we have access to a code editor and we have access to create tests. So we're going to start with the code editor. And this is the Blawx interface that you may be familiar with. What's changed in this version is that we now have two collapsible regions on the right and left. So the output problems and code section is now hidden on the right. And on the left, we have a new navigation window that allows you to choose the section of the act that you want to encode. So for our purposes, we're going to go through the rock, paper, scissors act, and we are going to encode it section by section. So let me show you how that works. We're going to start with section 1. A game of rock, paper, scissors has 2 players. So what we need to describe here for Blawx is that there is a thing called a game, and there's a thing called a player, and games have players. So we're going to do that by going over here, and we're going to say we know that game is a category, and we know that player is a category, and I'm going to quickly save to update our known categories, and then we're going to say a game has an attribute which we will call player. And let me just hide this so we have more room. And the player is any number of player objects. So we've said that game is a thing, player is a thing, and a game has players. And now what we want to do is we want to customize the way that this player attribute is going to appear both in the interface and in explanations. So right now if we go into the known attributes, it says game's player is blank, which is the default, but we can customize that. So we're going to grab the customization, and we're going to start with the name of the player, not the name of the game. And we're going to say player played in game. And we're going to save that. Now if we go into known attributes, you see the text has changed here. The same change will happen in explanations. So that's section 1. We've saved section 1. We go into section 2. What we learn here from this piece of text is that there is something called a sign. So we can create code to say that we know sign is a category. And save that. And now we know that there are 3 specific signs. So section 2a creates a sign called a rock. So we can go down into objects and say we know that rock is a sign. And because the next 2 are very similar, I'm just going to copy this outside block, save it, go to B, I'm going to change this to paper. Save that, go to C, paste it in, change this to scissors, and save that. So now we've said that a sign is a category, and we know that rock is a sign, we know that paper is a sign, and we know that scissors is a sign for each of those sections. Now we're on to section 3. The signs have the following relationships, and these are all beats relationships. We could describe the beat relationship in 3A because it's the first time it's used, but let's just put it in here to keep the other sections clean. So we're going to say we know that a sign has an attribute called beats. And again, we'll just shrink this down to have more room. And it beats another sign. And again, this is going to give us a blank's beats is blank, which is not exactly what we'd want it to say. So let's grab a customization block, and we're going to say blank beats blank. Save that, and now it's much easier to read. Okay, so that's our root for section 3. Let's go into 3A, and we need to say that rock beats scissors. So we know rock, oops, let's grab that, rock beats scissors. And again, the next two are going to be very similar, so we can copy this outside block, save that. We know that paper beats rock. Delete that, just grab paper, save that, go into C, paste again, and we know that scissors beats paper. And save that. And now we have only section 4 left. The winner of a game of rock, paper, scissors is the player who throws a sign that beats the sign thrown by the other player. So there's a couple of ontological ideas here that we didn't have before. We didn't know that games have winners, and we didn't know that players have throws. So we're going to have to create those concepts first. We're going to say a game has a winner. And the winner is a player. And we are going to say that a player, copy that in, has an attribute called throw, which is a sign. If we save that, we can look in here. Blank's winner is blank, and blank's throw is blank. Again, that might work, but let's customize. So we're going to say player 1 game. And we are going to say the player threw the sign. We save that. And now we've got some very easy to read green blocks here. So that's the ontological concept. Let's just collapse that down, save ourselves a little bit of screen room. And let's look at the other thing that we need to encode here, which is the rule. The winner is the player who throws a sign that beats the sign thrown by the other player. So how do we convert that into blocks? Well, this is a rule. So when we know some things, we also know another thing. When we know that there are 2 players in a game, so we're going to grab 2 of these played in blocks, put those up there, and we're going to say both people played in something that we're going to call game, and we're going to call the first one player 1, and we're going to call the second one player 2. So there's 2 players in a game, and they each threw something. So we're going to grab a couple of these, and we're going to say player 1 threw something, and player 2 threw something. And we're going to call those throw 1 and throw 2. Make a little room. And throw 1 beats throw 2. So, player 1 played in a game, player 2 played in a game, player 1 threw throw 1, player 2 threw throw 2, throw 1 beats throw 2. When we know all of these things are true, we also know that player 1 won the game. And there you have it. That's our rock, paper, scissors encoding finished. So, what can we do with it? Well, we can go back into the rule and we can create tests. So let's create a test called Bob Jane, and we will create 2 players and give them throws and see who won. So we're going to say we know that there is a game, and we will just call it test game. And we know that there are 2 players, so I'll copy and paste that, call one of the players Bob, and call the next player Jane. And we know that Bob and Jane played in the test game. So we're going to grab test game from here. And we're going to grab Bob there and Jane there. And now we need to know what they threw. So let's say that Bob threw scissors and Jane threw rock. Save that. Now, we know that if all these things are true, then it should also be true that because rock beats scissors, Jane is the winner of the game. So let's ask if that's true by grabbing a question block. Is it true that Jane won the test game? We can save that, or we can open up our results screen here and click Run. And it gives us one model, and it says Jane won the test game because Jane played in test game, Bob played in test game, Jane threw rock, Bob threw scissors, rock beats scissors. So you can see that this conclusion has been reached on the basis of the rule and the facts, and we got the answer to our question. We did this specifically asking about Jane, but we didn't need to. We can also put a variable in here and ask who won test game. And if we save that and run that, it still gives us only one answer, and it's the same answer. Had there been multiple winners, it would now give us multiple answers. So that's how that works, but there's a different kind of test that we can run in Blawx because we have some advanced reasoning capabilities. So let's create another test, and let's call it hypothetical. Let's go into our hypothetical test, and instead of giving some facts, let's give some assumptions. So we say assume that someone played in some game. And let's also assume that some player threw some sign. Now we can ask the question, is it true that anyone won any games? Which in this context, because there's no facts, is actually asking, is it possible, given these assumptions, for someone to have won a game, and if so, how? So we can save that. Let's open up our results, and click Run. And we can see there are 3 models that have been returned. So in the abstract, is it possible for people to win a game of rock, paper, scissors, assuming that there were players and that the players threw signs? Yes, in the abstract, there are 3 possible ways, and you can probably guess what they are. This text needs to be tidied up, but you can see down here at the bottom, the first scenario is one where rock beats scissors. The second scenario is one where paper beats rock, and the third is a scenario where scissors beats paper. So you can see that Blawx is not only able to take facts and apply rules to those facts in order to determine what a legal conclusion might be, it's also able to take a legal conclusion, like somebody won a game, and then generate the facts that are necessary in order to satisfy that. This is a very powerful technique that you can use to do all sorts of planning, and it's very, very useful when you are debugging your encoding of the law, because as you proceed, you can check and see what all the possible ways of getting a legal conclusion are. And if there's any in there that you weren't expecting, it means that you've made a mistake in your encoding. Or there might be a mistake in the actual law that needs to be addressed. So that's one of the ways that these features of Blawx can help with legislative drafting. So that's an example of Blawx version 1.1 alpha. Thank you very much for checking it out. And if you have any questions, I am at Roundtable Law on Twitter.